Today we're going to be working with parallel and perpendicular lines and then the equations of. So parallel lines have the same slope. I'm going to give you one slope as an example of, let's say 2/5. So a slope parallel would be exactly the same slope, same rise, same run, same tilt. So those lines would have different intercepts, but they would run parallel to one another. Perpendicular lines have opposite reciprocals for their slopes, and those are the slopes are the things that determine if they are parallel or perpendicular. So you could have a slope maybe of 2/5. We'll use that again as an example. The perpendicular, there's your symbol column. Perpendicular slope to that would be, flip it over because you need reciprocal, and change the sign. Since it's a positive, it will become a negative 5/2. Okay, so this is the only thing we're concerned about for checking if lines are parallel or perpendicular is their slope. The intercepts will always be in a different location. Well, I guess I shouldn't say always because perpendicular lines might both cross on the y-axis at the same place where they touch. So we won't use the word always. I do want to just kind of go through and do some examples. So that's what we're going to look at first. Let's take this equation of line right here, this point, and we're going to make a line parallel. I'm going to give you some steps that you can do on each of these. The first step is always going to be find your M, find your slope. So to make an equation of any line, find your slope. Second step is always going to be to substitute. When you have a point and a line or a point and a slope, substitute your x, your y, and your slope into y equals mx plus b. Okay, so you're substituting the y, the m, and the x so that you can find the b. Then the third step, again, for parallel, perpendicular, or just any equation of lines, these are your steps. The third step will be to substitute in the slope you found, M, and the intercept you found, B, into your y equals mx plus b equation. Okay, so that's just to find the equation of any line. First thing you have to have is slope. Second thing you have to find is the b, if it's going through a point. And then finally, you can use your slope you found and your b you found, your y-intercept, and make your equation of your line. All right, did we get the steps written?
Yes, ma'am.
So now we're going to apply those steps here. Where can I find my slope in the information they give me? And can I find it right away?
It's multiplied by x, so it's -4.
Okay, so it is going to come from the equation, but I don't want to see, I can't really see the slope right now because the y and the x are on the same side. So really, what do I need to do with that equation first?
You need to put it in slope
intercept form. So go ahead and write down the equation with me. -4x plus y equals -2. It's all examples, so you have your examples to look back at. We are going to move the 4x to the other side by adding it. So your equation will be y equals 4x minus 2. Now I can tell the slope is not a -4, but the slope is a
positive 4.
So I did my first thing. I found my slope. It is 4. Second step is to find the b. First of all, I need to realize they're asking me for a parallel line. So my slope, is it going to be the same slope? Or is it going to be the reciprocal slope?
For parallel, it'll be the same.
Okay, so I do have the correct slope. The next thing I'm looking for is what is my b. So that's when I go in, put the x, the y, and the m that I'm going to use. So I'm going to use this point, and then my y is -2. My slope, I should probably write this. I'm using this equation, substituting y, substituting slope, substituting x, needing to find the b.
Yes.
All right. 4 times 6.
Okay.
That equals -2. When I bring my 24 over, I will be subtracting it.
Oh no.
So that should give me a higher negative number, negative 26. Now I found my b. I'm going to go back up here. Negative 26 is my b. My equation of my line is my third step. So, oh, wrong thing.
Tyson! Hi.
Come on in, Tyson. We're taking notes. My third thing is to, so can y'all adjust that? Move it off. Or here, can you just sit what that is? That'll work. My third thing will be to substitute in. I found the m I needed, so 4x, and substitute in the b that I found. There is my equation of my line parallel to this. It's gonna be kind of hard for me to graph that on this graph because the y-intercept is at
26.
Yeah, negative 26.
What if we just went
Say that again.
What if we just went by 8?
We could have done the scale differently, but I am trusting that y'all will be able to graph those equations if we need to. I'll look at your assignment in just a second, Tyson. Okay, that was the equation of parallel line, same slope. Let's look at our example of perpendicular line. So we are just in our notes, Tyson, writing examples, doing examples. All right, first step, find the m that we are going to use. So I want you to write it down. Go ahead and write your equation real quick. Equation of line, this is example 2. Equation of line is negative 2x plus 3y equals 6. We want a perpendicular line through the point 1, 2. Okay, equation, perpendicular through point 1, 2. First thing we need to find is the slope that we're going to use. So can I see my slope right now? No. What's the first thing I need to do?
Put it in slope-intercept form.
Get it in slope-intercept form to be able to see my slope. I'm going to rewrite that. Solving for the y, I'm going to move my 2x over by adding it. So that will be 3y equals positive 2x plus 6. I will move the 3 over by division and all things. So y equals 2/3 x plus 2. Kyle, what's my slope?
2/3.
So I'm going to remember that. That's all I needed out of that equation. I don't need this intercept really. I don't need the equation itself. I only needed slope. So whenever I get my slope, I'm kind of done with the equation. So everybody get the equation written and simplified. I'll erase that. Step 2. What am I looking for next?
The y-intercept.
Y-intercept. So I need the b. Okay, so since I need b, I'm thinking y equals mx plus b. I'm going to put in all my information, and then the b will be missing. So I have my y coordinate of 2. I have my m. Oh, but wait. Is this the slope I'm going to need for a
No.
perpendicular?
It has to be the reciprocal.
Negative.
I'm going to flip it over. I'm going to use the reciprocal because I need the perpendicular slope of negative 3 halves. So I'll put that in here. Now my x of 1 and plus my b. Okay, so when we multiply, we get our negative 3 halves. What is 3 halves in a decimal? 2 goes into 3.
1.6.
1.5.
1.5.
1.5. 1.5. So I think for me, it's easier to add in a decimal right here instead of that fraction. So I'm just going to move it by adding that 1.5 to both sides. And my b is found at 3.5. You could have left it 3.5. You could have changed to a common denominator, whichever way you want to do that to add. Okay, finally, I want my equation. So now I erase all of this. And I go back. I have my y equals mx plus b. I'm now substituting the m and the b to get my equation. M, oh, which one?
Negative 3 over 2.
And the b I found
3.5.
plus 3.5. So all three of those steps, find the m, find the b, substitute, and make your equation of your line. No matter what information they give you, point, slope, 2 points, you can use that same technique for each one of those. I do want to go ahead and graph this one because I want to graph the original as well. Our original was y equals 2/3 x, what was it, plus 2?
Yes.
So that you can see the perpendicular. So this one, when I rise my 2 for my intercept and rise 2, run 3 for my slope. See if I can draw my line fairly. Yeah, pretty close. And then this one, so I'm gonna rise 1, 2, 3, go 3.5. As I do my fall 3, I'm gonna count on the halves because there's a 1, 2, 3, and then I'm going over 2. And when I graph through those points, hopefully you can see the perpendicular that was created. One is flipped to the other one. Okay. All right, feeling okay about making equations of lines? That's really all we discussed, Tyson, so far, other than parallel lines have the same slope and perpendicular lines have the opposite reciprocal slope. One last thing. We have our slope formula. I want to see if we could find a missing value of a coordinate given the slope. So let's see if we can work that slope equation backwards. Slope equation I gave you was the little rat's tail. Okay, so it's not going to be as easy for this one, but we can set it up that way. So I think I'm going to do that. Or you can use the formula. I like to look at the coordinates as they are shown. 8, -2, and then r. Ooh, fine, I'll leave it an r. And -6. Sometimes my r's are hard to tell what that is. Okay, so your final example of right now, I want to find what I can of my slope. I have the change in y over the change in x. What's change mean mathematically? Subtract. I remember this process from Tuesday. So subtract. 8 minus r. Ooh, I can't really do anything there, right?
Yeah, you just have to put it 8 minus r.
I just have to put it 8 minus r. And I want to put it in some color that maybe you can see. I don't know if you can see that or not. And then -2 minus -6 becomes what?
4.
Okay, so now I'll put it back in the color we can see. This is my slope. 4 over 8 minus r. My rise over my run. I didn't find my slope, but look, they gave me the slope. My slope
Yes.
equals -4. How can I solve that?
So wait, why did you use like 8, -2? Like on the same
I
across from
used
each other.
Okay, so I used the coordinate points. This is just one method. You don't have to use this method. But if I were doing the equation, y2 minus y1 over x2 minus x1, I'm just using for the bottom, I was using my 2 x's, and I did 8 minus r on the bottom, that minus that. And it doesn't have to be r minus 8, it can be 8 minus r, as long as you go the same direction for both of them. And then my other part of my equation, my y's, would be -2 minus -6. It's just, so I have the same answer here that I get from this. I just like to use my table, so I'm always seeing my xy coordinate points and then subtracting down around the little tail. Okay, so it's the equation, but it's in this format. All right, so what could I do? What do you see to do here to solve for r when I made this slope that I found equal that, because I want to find the value of r?
Multiply by 1/4.
Okay, that would be a good thing, except for it would also leave this on the bottom of a fraction. So when you get to a situation that looks like this is my suggestion, because if I put that slope over 1, I now have a proportion. Do you remember what you do to solve proportions? That is it. It is a cross multiply, and it makes it, instead of having to worry about like moving fractions, it makes it easier to solve. You're going to cross multiply only if there's an equal between. So I'm going to be multiplying my 4 times my 1 to get 4. and I'm gonna be multiplying my -4 times all of this. So I'm gonna include it in parentheses. 8 minus r. Now, I don't have any fractions anymore. I didn't have to worry about moving. I'm multiplying times 8 minus r and solving. All right, solve it out, see what you get. Yes. Are we getting 9? Okay, so distribute -32 plus 4r, so add your 32, divide by 4, and r equals 9. So the coordinate point for x right here, or the number would have to be 9 to make this slope become -4. Okay, it's just a matter of using the slope formula. How do we feel about this?
Good.
Ready to try some of your own? Okay, thank you. I'll get your assignment.